So in Unit 4, we're going to be talking about polynomial functions, and we're going to mainly talk about x to the third power, x to the fourth power, cubic and quartic functions. Now for today, it's going to be fairly simple. The first couple of questions are just calculator questions. So they want us to sketch the graph and find the roots of each of these functions. And so we're just going to type them into the calculator. So let's see if I can get a good view of this. There we go. All right, so when we're typing this into y equals, and remember, when you go to y equals, a negative sign on this calculator is actually a separate button. So negative x raised to is going to be this key right here, raised to the third plus 4x squared plus x minus 7. Alright, I'm going to zoom 6 the graph so that it's a standard window. And we can tell that it crosses between -1 and -2. It crosses on the right hand side between 1 and 2, and again between 3 and 4. And so those are the main things we want to make sure that we keep our x's in approximately those places. So somewhere between -1 and -2, over here between 1 and 2, and then between 3 and 4. And our graph comes down, comes back up, goes back down. All right, so it says that they want us to find the roots. So we're going to find the roots by second calculate. Turn the second calculate screen, second calculator, second trace the 0. And then we're going to use our left, right arrow keys to go left and right of each of our zeros. So there we're on the left. Push the right arrow, move to the right, hit enter. So that one is at -1.23, or sorry, -1.253. So this one is at -1.2530. And we're going to do that again for this next one. So second calculate the 0. And then move left and right at that point. And we've got 1.480. And then that third one, second calculate the 0. Oops. Left and right. And that one's at 3.773. All right, so something that I'd like you to notice here is that this was an x to the third function, and it had 3 roots. All right, now we're going to do the same thing with the x to the fourth power function. So if you're taking these notes online, I would probably go ahead and try this yourself. Type it into your calculator, sketch it, see what you get for the roots, and then come back and check with me. But we will go ahead and put this on here. So we're going to type that into the calculator. All right, so we get it typed in. We look at our graph. We're going to sketch the graph. If you want to change your window up so you can see the bottom of that, but we're not really concerned about the y values right now. So really it's just the x's that are going to be important to us. So we want to make sure we have those in the right place. This one looks like it's between 0 and -1. And this one between -2 and -3, over here between 0 and 1, and then between 3 and 4. And so we're going to calculate each of those values. So second calculate the 0. We'll go left and right of each of those. Didn't mean to go that far, but there we go. So we have negative 2.502 if we round it up. So let's go ahead and sketch this one real quick. So there's our sketch, and that first zero was at negative 2.502. All right, so we're going to do that for all of these zeros. This second zero is at negative 0.6500. The third one is at 0.7160, and the last one is at 3.4360. And this one is a fourth power function, and it has 4 roots, 4 zeros. So that's going to be important to what we're studying here. This one is the cubic graph. This one is a quartic graph. And the idea here is that for a cubic function graph or an x to the third power graph, you could have 3 roots, but you will never have more. You could have less, not more. For a fourth power function, you could have 4 roots, never more, but you could have less. So let's take a look at our parent functions for these two graphs. So for the x to the third power graph, just like we did on all of our parent function graphs for our last unit, we're gonna choose some values for x and just plug them in. So I'm going to do negative 2, negative 1, 0, 1, and 2. And so when I plug in a negative 2 raised to the third power would be negative 8. Negative 1 to the third power, negative 1, 0, 0, 1, 1, and 2, 8. And so that gives me my anchor points for the x to the third power function. So I've got negative 2, negative 8, negative 1, negative 1, 0, 0, 1, 0, and 2, 8. And this one gives me that S curve. Some of you may remember Mr. Krauss calling this a sigmoid, but it is an S-shaped curve for a cubic parent function graph. Since this thing does seem to be getting wider, even though it's just a little bit at a time, its domain is going to be negative infinity to infinity, and the range also negative infinity to infinity. And then for the x to the fourth power graph, do the same thing. I'm going to pick a few extra ones here. So negative 1/2, 0, 1/2, 1, and 2. And so we're going to raise each of these to the fourth power. Well, negative 2 raised to the fourth power is going to be positive 16, which is a little too big for our graph. At negative 1 raised to the fourth power, I get 1. 1/2, negative 1/2 raised to the fourth power, 1 to the fourth power was 1. 2 to the fourth power was 16. So I'm going to get 1/16. 0 gives me 0. 1/2 is still going to give me 1/16. 1, 1, and 2, 16. So what we can tell is that this one at negative 2 is 16. I'm going to put it out way up there, even though it's off the graph. And then we've got negative 1, 1. We've got negative 1/2, 1/16, which is right along the line, then 0, 0, then 1/2, then 1, 1, and then 2, 16, way up there again. So this thing grows very, very rapidly, very quickly, but it kind of, at the bottom, flattens out across the bottom. So it's going to look very similar to the x to the second power, or just the parabola function, but it is thinner because it goes up faster, and it's flatter across the bottom because these fractions are going to stay very small. But my domain is still negative infinity to infinity. My range, 0 to infinity. Alright, so I'm going to show you really quickly on the calculator what these two graphs look like. This is just your parabola, x squared parent function graph, and then this x to the fourth power graph. So I'm going to change my x to the fourth power graph so that it graphs a little more slowly so you can see it. Alright, so when it starts to graph, it's going to graph the x squared function first, and then this is the x to the fourth. Alright, and so if you can see right across the bottom, that x to the fourth power was inside, but on the bottom it's much flatter. So these are going to be flat across the bottom. Okay, so we're going to do transformations for these two parent function graphs, same as what we did in our last unit. This one, our parent function this time is x to the third power. They want us to stretch it by 2 and then take it 3 units to the right. So we're going to end up with y equals our stretch of 2, and then identify our function. So it's going to be an x cubed function, and it's going to the right, so minus 3 cubed. So we're going to take our original values and we're going to change them up just like we did before. So for our original values, we had negative 2, and then 8, negative 8, negative 1, 0, 0, 1, 1, and 2, 8. And so for the x's, we're going to add 3. For our y's, we're going to multiply by 2. So add 3, so we're going to get 1, 2, 3, 4, and 5, and we're multiplying the y's so by 2, so negative 16, negative 2, 0, 2, and 16. Alright, so these are not all going to fit on the graph, just graph the ones that fit. So we're just graphing these right here. So we've got 2, negative 2, 3, 0, and 4, 2. Now it looks like a line, so you've got to know that this is a cubic function graph and make it look like one. So we know that this is shooting up very quickly. This next number over would have been 16. So it's going up on the right hand side and down on the left hand side. So our domain, again, all real numbers, negative infinity to infinity, and our range also all real numbers, negative infinity to infinity. Alright, same thing with the x to the fourth power as our parent function graph. This time they want us to reflect it and take it 2 units down. So reflection is going to go in the front as a negative, and then we have our parent function, which is x to the fourth power, but there's no shift. So if you want to put the x in parentheses, you can, but no left, right shift, and then down 2. So we're just going to take the values that fit, which really there weren't very many. It was just negative 1, 0, and 1. And again, you have to remember the shape because these by themselves are not going to give you the shape of the graph. So for the y's, we are multiplying by negative 1, and then we're going to subtract 2. The x's are just going to stay the same. So we're multiplying by negative 1, so this is going to be negative 1, and then subtract 2, so negative 3. Multiply by negative 1, still 0, subtract 2, so negative 2. Multiply by negative 1, we get negative 1, subtract 2, negative 3. So we've got negative 1, negative 3, 0, negative 2, 1, negative 3. Remember that this is a fourth power function, so it's going to look kind of flat across the bottom. And it's going to go down since it was reflected. So our domain, negative infinity to infinity. Our range is negative infinity to negative 2. In this last section, we're going to write the equation given the graph, so you need to know the shape of the parent function. This parent function, this shape is an x cubed graph. Also, you need to know where it was placed originally. This point, the center of that curve, was at the origin, and so we're going left 3 and up 2. We're not going to worry about the shrink or stretch unless they give us a point, because these are a little difficult to determine. They're all pretty thin. So y equals, and then our left right shift goes inside, so x plus 3, identify the parent function, cubed, and then plus 2. This one, x to the fourth power parent function. This point here was at the origin, so it's moved left 1, 2, 3, 4, and down 1, 2, 3. So we have y equals, our left shift would be plus 4, identify the parent function, fourth power, and then down 3. So the same as what we did in our last unit with our other parent functions.